All right, so as we've mentioned before, you can't compare two strings with equal equal. You have to call dot equals. Pass one in and pass the other in. References that hold our objects are the same. For example, if we do this, car1 equals new car, car1 color equals red, car2 equals new car, car2 set color red. If car1 is equal to car2, print the same. We'd think they were the same. They have the red color. But it's not checking to see if they're the same. It's checking to see if these addresses are the same. And the addresses are different. Right? It's like having two identical houses next to each other. No matter how identical the houses look, each house has a different address. And that's all this is checking, to see if those addresses are equal to each other. So to make it work, we'd have to add a dot equals method. So we would have to do something like this. If car1 dot equals car2. But to get that to work, we have to add a dot equals method in order for it to work. So we'd have to go into our class and add dot equals. So equal equal is not good enough. We usually want to compare the contents of two objects. So to do that, we need an equals method in the object's class definition. Have we done the fraction class yet? Where we did a greatest common factor and multiplication of fractions?
Yeah.
All right. So if we were going to compare our two fractions, we would need to implement a dot equals method in them. I don't know if I can find our fraction fast enough. Here it is in Lecture S. In Lecture S, we had a fraction class. And whenever we changed it, we called dot simplify to make it easy. If we were going to add a dot equals method to it, it would look something like this. You don't have to go back and add it. Public Boolean, because it's going to return true or false. Equals, like I said, you don't have to go back and modify it. And it's going to take another fraction as its parameter variable, so it'll be an argument. Then you do things like this. If this dot numerator is not equal to other dot numerator, return false. And then if this dot denominator not equal to other dot denominator, not demon, other dot denom, then return false. And then if all the pieces have not turned up any differences, then we can say that the two fractions are the same, and we can return true. Now, this is not technically the best way or the most complete way to implement an equals method. And although it's more of a Java 2 kind of thing, I'll go ahead and show it to you anyways after a little bit. But you always want to add a dot equals method if there's a chance that you're going to be comparing two things. So back to my little rules of thumb. Data should be private. You know, Professor Thompson's rules for classes. I'm going to ignore the little bit about capitalization, right? All classes should begin with a capital letter. Every class in its own file, right? So rule 1, data private. 2, methods public. 3, getters and setters. 4, constructors if it makes the class easier to use. And 5, dot equals if you are going to compare objects. You don't have to if you're not going to be comparing them. And 6, a toString method to make printing the object easier. Like that. So those are rules for the classes, my recommendations. And every time I say them, I may put them in a different order or maybe leave one of them out. But that's pretty much what I want. So let's make another class. Well, let's go and look at the PowerPoint. Testing objects for equality. So to do that, you have to add a dot equals method. Passing a reference as an argument. This is a good thing. This is a good thing to talk about. Let's go ahead and create a class that's got an x and a y and a z coordinate, like a point. So if I'm correct, we're on Lecture U. So I'm going to make a new project, call it Lecture U. Take the package declaration out. All right. And so I want to make a point class. So I'm going to come over here to Projects, find my lectureu.java, and right above it, right-click on Default Package or whatever package you put it in, and do New Java Class. And I'm just going to call it, there already is a class called Point, so I'm going to call it MyPoint, just to differentiate, right? Because there already is a class called Point, and I don't want any conflicts. All right, a point's got 3 pieces of data. Int x, comma, y, comma, z. So when I'm ready to create a point, I can do it like this. Point P1 equals new point. And then I could set x, y, and z, except it's actually my point. Sorry about that. I'm going to call it my point. P1 equals new my point. Then I can set its x, y, and z values accordingly. But for one thing we've always said is make your data private. I'm skipping that for now. And then add a constructor if it makes it useful. Well, rather than type P1 equals 10, P1.y equals 20, and P1.z equals 30, I want to be able to do it with a constructor. Meaning I want to be able to pass the values in like this. If I want to point at 0, 0, 0, there should be commas. That's what I want it to look like, right? However, there is no constructor that does that. So I'm going to add one. What is a constructor? A constructor is a method that has the same name as a class. Constructor is a method that has the same name as a class. No return type, not even void, and is called by the new keyword to make a new object. So we need a constructor that will accept 3 numbers. It could be doubles, they could be ints. For some reason I made these points ints, so I'm just going to, I'm going to change that to double. Makes more sense. Because you'd have something at 3.5, comma 1.2, whatever, right? So I'm going to make the myPoint class, whoopsie. I'm going to make those variables be doubles. And just to remind ourselves how to do setters and getters, I'm going to add one setter and one getter and then let the encapsulate do the rest. So a setter doesn't need to return any value. So public void set x parentheses. But you do have to pass in a value, int x in parentheses. All right, and then we say it, this dot x equals to x. So this dot x, you can tell it's green, so it hooks up to that variable. This x is black, so it's hooking up to that parameter variable. So that's what a setter looks like, and a getter does have to return a value. Why did I make this int? I have ints on the brain. What should that be if I'm going to set x? Double. Yeah, all right, so double. All right, and so the getter should return double. Public double get x, but it doesn't need to accept a parameter. Return this dot x. All right, so I added a getter and a setter. But I'm in a hurry and I want to do it for the y and the z as well. So I'm just going to highlight my variables and go to Refactor Encapsulate Fields. So for the refactor menu up here, refactor, encapsulate fields. May as well select them all. Click refactor. And it adds a whole bunch of comments and it moves my variables down to the bottom where I don't like them. So I'm going to go and cut my variables and paste them back at the top. And I'm also going to remove these excess comments. It's the price you pay for using the NetBeans to generate the getters and the setters. There's my variables, so I'm going to cut those and paste them up at the top. Now I haven't handled the big thing that I was talking about, which is the constructor. But at least I've added my getters and setters. You know, I'm kind of following my rules. Data private, methods public, add getters and setters. Add constructors if they make the class easier to use. Well, being able to pass in data while we're creating it certainly will make the class easier to use. So let's do it. Public, because a constructor pretty much ought to be public, or else you couldn't call it. My point, parentheses, and it needs to accept 3 arguments, so we're going to define 3 parameter variables, x, y, and z. Double x, comma, double y, comma, double z. And what's it going to do? It's going to set x, this dot x equals x, this dot y equals y, and so on. This dot x equals x, this dot y equals y, and this dot z equals z. Now when I save that and I come back over here, the error should go away, right? And it did. So I can call my point P1 equals new my point 0, 0, 0. And I have a rogue S here that I typed here. I need to delete that. Okay, so that's what our constructor looks like. I'm not going to bother adding a default constructor. Do remember that once you add a parameterized constructor, your default constructor is no longer provided. So you can no longer do this. This would be a syntax error. May as well not even type it. My point P2 equals new my point won't work, right? Because we've lost the default constructor. But we can always add one back. Why not add one back, right? Public my point. And since it's a default constructor, it just doesn't have any arguments. No parameter variables. So open curly brace, closed curly brace, semicolon. That's the default constructor. This other one is the custom constructor, the parameterized constructor. Parameterized constructor. Well, I guess since we have our default constructor, you could go ahead and create it like that. But then you'd have to set the x, y, and the z values, right? P2 dot set x equal to 10, P2 dot set y equal to 11, and P2 dot set z equal to 12. And what if we wanted to see if they were the same? Obviously they're not, right? But even if we did this, even if we said 10 and 11 and 12 here, if we did if P1 equals P2, system.out.println P1 equals P2, but they're not, so when I run it, I'm not going to get that message. In fact, I'm not going to get anything because we're not printing anything out, right? So when I run it, when it finally finishes running over here, it says build successful. It is not printing anything. I could put an else here to make it print something if they're not the same. At least that'd be a little bit better. Else system.out.println P1 does not equal P2. End quote, close parentheses, semicolon. Now when I run it, it's going to say P1 does not equal P2. And the reason for that is that you cannot compare references with equal unless all you want to do is check to see the addresses are the same. The addresses are never going to be the same. Well, I mean, I guess it could be. That'd be the only time that that's going to work, and that it would say that they're equal. Normally the addresses aren't going to be the same. So we're going to need to call dot equals. P1 dot equals parentheses P2. Let's see if that thinks that they are the same. See if it says return true. Nope. That's because we have to go and add our own dot equals method. The object already has a dot equals method, or else this would have not compiled. But it doesn't do anything useful. It just checks to see if the addresses are the same. And they're not. So we're going to go and add a dot equals method. How about here under the constructor? Public Boolean equals. And what's it going to take? It's going to take another point. So my point other. But we're going to get fancy. I don't know why I'm getting fancy, but what do I mean is, say I had done something dumb like this. String S, and then if, don't type this because I'm not planning on making it. Well, I keep saying don't type this and then I make you type it. But anyways, like if P1 dot equals S, right? That's a syntax error because it's expecting a point there. I think that's good enough. I don't think I want to go into the idea of comparing two different objects if they're not of the same type. So forget that. Go away. Alrighty, so we have to check to see if X, Y, and Z are different. And if they are different, return false. If they're not, return true. So if this dot X not equal other dot X, in parentheses, return false. And there's always different ways you could write this. I just think this is the best. If this dot Y not equal other dot Y, return false. And you can see where we're going with this. We're going to do the same for Z. If parentheses this dot Z not equal other dot Z, in parentheses, return false. But if we've passed all those tests, it means that they're the same. So we can return true. And one thing we could do at the top, just to speed things up, is we could check to see if the addresses are the same. Now, if the addresses are the same, all these things should be the same anyways. But just for speed things up a little bit, we're going to do if this equals other, return true. Right? Because if the object we're comparing, if we're comparing it to itself, then the other reference will equal this reference. And we want to just bail out as soon as possible. There's no reason to keep checking if we know that they both point to the same memory address. So that's what that's handling right there. So make sure we aren't comparing to ourselves. That's all that that's doing. And then check each member variable. Or each instance member, if we want to say. Instance variable. Why are we getting an error here? The if statement is redundant. Says who? Oh, wolf. Yeah, no, I don't care. All right. Sometimes the changes that NetBeans offers to make are too clever by half. I don't feel like accepting that change. All right, now I can compare the two objects. If I'm done with all that typing, I could change this. It looks like I already did. If P1 dot equals P2. Now it's going to say that they are the same because they have the same data, 10, 11, and 12. And so, as a matter of fact, that was loud, P1 does equal P2 because the data is the same. And if we change one of these variables, this one says 10, 11, 12, and this one says 10, 11, 13, they're no longer the same. Yep. Now, in the C++ programming language, you can do what's known as operator overloading, or operator overriding, sorry. which means that you really could write this. If P1 equals P2, you can actually dictate yourself what equals means. Not in this language. Doesn't work. Just compares addresses, not contents. So we provide a dot equals method. So now let's print our object out. System.out.println P1, system.out.println P2. And since we did this on Thursday, you know that it's not going to print anything useful. Bless you. So it just prints out the name of the class and this hashed memory address right there. To get that to look good, what kind of method do we need to add? It was in Prof's rules. What is number 6? Yeah, we're going to add toString to convert our object to a string. So without it, we just get this gobbledygook. As soon as we add it, it's going to be a lot better. So let's add toString, but let's make it the simplest one possible and then expand upon it. Public, capital S string, T-O, uppercase S string, parentheses in parentheses. Just return the word my point. End quote. Just to prove that it's doing something. So when I run it, it's not going to print my point followed by this memory address. It's going to print whatever I got here, like if I put a couple asterisks there for some reason, just so that they'll show up here. And it did, right? So when I tried to print it out, like that, whenever you try to print something, it's expecting a string. If it's not a string, it calls that object's toString method, which we just provided. And that one's kind of lame, so we're going to make a better one. Why not use string.format? So string s, s.format, quote, my point, parentheses, %d, comma, %d, comma, %, except that's for ints. What is it for floats? I always do this. It's f, %f, comma, %f, comma, %f, in parentheses, end quote, and now we need to pass in our 3 variables. So after the comma, this dot x, comma, this dot y, comma, this dot z, in parentheses, semicolon. And then the next line, let's return that. Now I've made a mistake, and I'm sorry for that. Instead of s.format, it's s equals capital S string.format. But string.format looks just like printf, except it's making a string rather than sending something to this visual output. So now when we run it, it's going to print out that it's a my point, but then it's also going to print out x, y, and z, which is useful information. And indeed it did, right? My point 10, 11, and 12. Anybody need eyes on your screen? More time to type? Are we all good? All right. So, every one of these things is inherited from a class called object, which you never use on your own, but you could. You could go object, whoopsie, what are you doing? Object O equals new object. Now we wouldn't want to do that, but that's a totally generic object. Totally generic. It doesn't have any data in it at all. We could do if O dot equals, you know, O, then do something, right? And it better, right? Because it's checking the memory address. And so O, the object class, has a dot equals method and it has a toString method. But we replaced those methods. I'm going to delete that stuff because there's absolutely no reason to ever create an object, the most generic object possible. But we replaced the toString method and the equals method. So that's what these little comments over here, these warnings, add the @override annotation. You can do that, you can take it or leave it. It just means that we're replacing the toString method that we inherited from something up higher in the hierarchy. We're not going to talk much about inheritance in this class. That's a Java 2 subject, really. Advanced Java subject. But it does get rid of the error. Same for dot equals. I'm surprised that there's not. Oh, that's because if we want it to be an exact override of the equals method that we inherit, we would have to change this. We may as well go ahead and make it 100% correct. So what we're going to do is we're going to change my point other to capital O object other. But the first thing we're going to do is we're going to try to turn it in to a point. My point, whoopsie, this is annoying. Forget it, leave it alone, undo all those changes. Except for that comment. I did like that comment. So passing references as arguments. You can certainly do that. We can pass one of these objects as an argument. I could come up here and add a new method to my lecture class. I'm not sure what it's going to be called. How about just reset? And all it does is set the variables to 0 or something that is passed in. Right? So public static void reset, and it takes an object. So capital M, my, capital P point. I'm just going to call it P, comma, and it's going to set X, Y, and Z equal to this integer that's passed in, or this double that's passed in. And so P dot X, or excuse me, P dot set X parentheses X, P dot set Y parentheses X, and P dot set Z parentheses X, right? Just, that's all it does is set the X, Y, and Z instance variables of the point to the specified value. And maybe we shouldn't call it X because we have an X, Y, and a Z, right? And here we're calling it X. So maybe we should have called it I or D or value or something like that, right? Say I decide that that's the case. Say that I decide that this is a bad variable name. What am I going to do? I'm going to rename it. So I'm going to double click it, right click, and choose refactor rename, or I'm just going to double click the X, come up here, and choose refactor rename. And I don't think X is a good name for that variable, so I'm going to call it value and click refactor, and there, I like that better, right? Set the X, Y, and Z instance variables of the point to the specified value. So it's perfectly fine to pass this variable in, to pass in point, and have it change the values. That's totally fine. I don't know what that is. What did I just do? All right. It's messing with the comments, so I'm going to delete some of the comments. All right. However, the method cannot change P itself. It can change the methods, but it can't change P itself. It's kind of like if I give you the address to my house, you can go and paint my house a different color, but you can't make a brand new house. You can't change the address. And we could kind of prove that to ourselves by doing something like this. This isn't going to work. Public static void change parentheses my point P.
in parentheses. This just flat out's not going to work. P equals new, capital M, my, capital P point, parentheses, -1, comma, -1, comma, -1.
Looks good, right? But let's prove that it doesn't work.
So down here, I'm going to create a new point. My point P3 equals new my point, parentheses 1, comma 2, comma 3 in parentheses. I'm going to call the reset method just to prove that it works. Reset, parentheses P3, and let's print it out. Oh, set all the values of P3 equal to like 21, or
who cares? Now let's print it out to make sure that they really are all 21. System.out.print ln parentheses quote P3 equals end quote plus P3. Now let's call change. Change P3 in parentheses. And let's just print it out again. So I'm just going to copy that. But I'm going to add a comma. This is after reset, comma, P3 equals that. And this is after change, comma, P3 equals plus P3. This is going to work. It will be changed so that every value is equal to 21. However, this one's not going to work. It's not going to find out. It's not going to find a point with all the -1s set. So if I scroll over here, take a peek, right? So after the reset, the values are all equal to 21 because that's what we reset them to, and after the change, they're still equal to 21. Now this is a subtle thing. Java is a pass by copy. It's a pass by value language. It's not pass by reference. Meaning that when this runs, it copies the contents of the address of P3 into here. And once you have my address, you can go and change parts of my house. Right? You could paint the shutters, you could, go and water the lawn, you can do whatever you want to. That's what this is doing, is it's using that address to change the values of that object. Right? It's repainting my house. However, if I call this one and it passes in P3, P3 is a copy of the address, right? And then it tries to create a brand new address. Well, great, you've got a brand new address, but I've got my original address, so I have my original house. No changes were made to my original house. So this just flat out didn't work. Doesn't work. P is a copy of the address of the argument passed in. So creating a new value for P doesn't do anything useful. However, up here, P is a copy of the address of the argument passed in, or that the argument passed in contains. P is a copy of the address that the argument variable contains. So we can change and access its instance members. And this doesn't work. P is a copy of the address that the argument variable contains. I kind of hope that makes sense. I hope that you can see when we copy P3, we're not actually copying the object in. What we are doing is we're copying the address of the object in. And once you have the address, you can go and do things to it like that. However, you can't change its address. It doesn't do anything useful. If you change the address, great. You have a different point out there, but it didn't modify this point, which is why when we print it out after the change, everything still equals 21 and not -1, -1, -1.
So a swapping algorithm. Write a pseudocode fragment that swaps the contents of x and y. This seems to be a strange place to be mentioning that, but okay.
If you need to swap two variables, what you got to do is create a third intermediate variable to hold
a temporary variable. Like if you have int x is equal to 10, int y equals 3, and you want to swap those, you better make a temporary variable.
Set it equal to one of those. And then you can set the value of that to that, and then you can say that y is equal to temp. Right? That'll work. Temp is equal to x, so now we have the value of, whoops, I think I've done something wrong. Definitely. That should be y equals x.
What's wrong with my brain? Temp is equal to x, so x is equal to y, and then y is equal to temp. So we make a backup copy of x. We store it in temp. We reassign x with the value of y, and we copy our backup copy into y. So that's how you swap two variables. Use a temporary variable. And we're getting comments here. The assigned value is never used. Okay, fine, because we never printed out x and y, right? I'm not going to add some code to print out x and y just to make the warnings go away. So method call chaining. Method call chaining means that you can call multiple methods in one line. Like what if we wanted to do this? p3.setX to 10 in parentheses dot set y to 20 in parentheses dot set z 30. Now that doesn't work, but we can change it so that it works. That's called call chaining. And if you like it, then you could go and make the changes necessary to make it work. So what's it doing? When we call set x, it's returning the object so that we can call set y on it, which is returning the object so that we can call set z on it. And by the time all that's done, then x will equal 10, y will equal 20, and z will equal 30. Now, I really honestly don't do that very much, but we could. How do we do that? We make the setters return this reference. That's what it takes in order to do call chaining, is that these methods have to return this. So they're no longer going to be void. Let's go find our setters. So set y is no longer void. It returns a my point. And after copying that value in, the next line should be return this. And do the same thing for set x and set z. So I'm going to come down here to find set z. It no longer returns void. It returns my point, a reference to this object, so that the return statement here can say return this. Not thus, this. And now I need to find set x and do the same thing. Wherever that is. Oh, it's right there. Does it return void? What does it return? My circle. And it needs to return this reference. Now I could chain all those calls.
Returns my point.
Yeah, my point. Sorry. My point. Thank you.
All right. So now the chaining works. Eventually that little error over here should go away. Right? You can go away on me, huh? Okay, finally it did. So anytime you want to be able to chain calls like this, you're just going to have to make those methods return this reference. Now there's a lot of kinds of methods that you won't be able to do that on, right? Because getY is actually supposed to return a value. So it can't return this when it's already returning a value, when it's returning this .y. And getZ is returning this .z. You don't have to make those changes I did. I just like seeing this in front of it. So that's what call chaining is. that sets up a call chain. But if we were done, then when we print out P3, it's going to print out 10, 20, and 30. System.out.println parentheses quote P3 space equals space end quote plus P3. So when I run it, we're going to see that P3 is now equal to 10, 20, 30. So a comment to add. I don't know where our comments were, if we've even added any notes. I thought we had. Okay, so for call chaining, the methods to chain must return this. Example, if we were going to have our circle class with a set radius, right? Class circle, you know, and it has a set radius. Instead of being void, it need to be a type circle. Set radius, int radius, and then this dot radius equals radius. Return this. This dot radius equals radius. Return this. Now we have a setter that can be chained with something else. Of course, this isn't a complete class because it doesn't even have a radius to set, which we could do, right? Private int radius. You certainly are not expected to type in these things that I'm typing in a notepad if you want to. So since set radius returns this, it could be chained. Now since it's the only method in here, there's nothing to chain it to except itself, right? C1 dot set radius parentheses 10 in parentheses dot set radius. This is silly, right? By the time it was done, the radius would equal 30. Now that's dumb, right? It's just that I only had one method, so that's why I did that. So overloaded methods. Suppose there's a need to perform the same task on different sets of arguments. You want to find the average of 2 numbers, or 3 numbers, or 2 doubles, or 3 doubles. What we would have to do is provide, okay, here's what their first guess was. Find average for 2 ints. Find the average for 3 ints. Find the average for 2 doubles. Well, that's annoying to have to specify your data type like that. It'd be better if it just said find average and it didn't care whether you were passing in integers or doubles. So let's go above our main method and add some methods that are overloads of each other called find average. So I'm going to go up to public class Lecture U, and inside it, I guess right above main, it's going to return the average, so it better be a double. Public, double, average, and this one's going to take 2 ints. Int x, comma, int y. Or I could make it int I1, comma, int I2, right? Now, I didn't spell average correctly. So double result equals x plus y. Result slash equals 2. Return result. Well, that's great, but it doesn't work with doubles. Let's provide another method that works with doubles. And what do I mean by that? If I came down here and I tried to get the average of several ints, it would work, right? So double A1 equals average 10, comma 20. That's great. But if I try to do double A2 equals average 10.1, comma 20.1, it's not going to compile. In fact, that one didn't either. It says non-static method cannot be referenced from a static context. I made a mistake, and what am I going to have to do to fix it? This is aligned with the mistake. The other one's a mistake too. but this is a line that I'm worried about right now. The comment is non-static method cannot be referenced from a static context. What did I forget to do? Compare this method to this method. What did I do different in this one that I didn't do in this one?
Not static.
Yeah, I didn't use the static keyword. If you're in a static method, every other method in the class that you're calling has to also be static.
So I better go and add the word static here. Now to compile. But this one won't, because we don't have a version that's accepting doubles.
I'm just going to copy it and paste it and change the word int to
Double and be done with it. Be fast. So double x, double y, double z. Now the reason it's complaining is I now have two methods with the same name and the same parameter list.
I now have two methods called average that take two integers.
Well, that's not what I want. I want one of them to take doubles. Now, honestly, at this point, it's kind of silly because
if something accepts a double, it will also accept an int. But I'm going to ignore that, right? And then let's make one more that'll accept three values so that I could do this, 10, 1, 20, 1, 30.1, right? If I wanted to get the average of those three doubles. Well, to do that, I'm just going to copy this and make some more changes, or I could retype it.
Public static double average is going to take three variables. Double D1, double D2, double D3.
And in here we're going to say double result equals D1
plus D2 plus D3. Result slash equals 3
because we have three numbers now, and return result. So now we can do it either way, right? We can get the average of two numbers, right? 10.5 and 20.7, or we can get the average of three numbers. And we're getting to use the same method name, which just makes for cleaner code. It makes us not have to sweat so much what kind of numbers we're passing it. That'd be really annoying if we had to call this an average two ints. Don't make that change. And average three doubles.
Yeah, you could. There's no need to. We don't need to make our code that ugly if we have the ability to overload our methods.
Overloading is not bad. It's not like Captain. The engines are overloading. We're about to, she's about to blow.
Overloading is providing multiple methods with the same name but different parameter variable lists.
And it's just so that you can make kind of the language of your program make sense, right? Call average with two variables, call average with three variables, it all works. We could write another one that accepted an array and would calculate the average of an array. That'd be kind of neat. Let's do that.
Public static double average, parentheses is going to be an array of ints. Why not? Int square brace array close parentheses double result equals 0,
and now we're going to use a for each loop. We're back to arrays all of a sudden. For parentheses int value colon array in parentheses result
plus equals value.
And now we need to divide it by the length of the array. Result divided by equal array dot length return result, right? So we can do the same thing. We could create an array and pass it into the average method. We could pass in some numbers individually, and we get to use the same method name. Kind of just makes it cleaner looking code. So if we want to declare an array to pass in, int square braces ia equals curly brace
10 comma 2 comma 5 comma -1 in curly brace semicolon, and then double A3 equals the average of parentheses IA. The code will blow up, by the way, if you pass in an empty array. Or at least it's going to give you a garbage value. What is an empty array? It's one that looks like that. Doesn't have any members at all. So what is dot length equal to? Dot length is equal to 0, and dividing something by 0 does not give you a result that you like. So I'm certainly not going to do that. I'm going to leave it with some good data there. Don't remember what that green line is. I guess it's the area of the screen that it's recording. I'm surprised it's not recording the whole screen though. Oh well. Now I didn't print out these averages or anything. Why not? String S semicolon S equals capital S string dot format in parentheses quote A1 equals %F comma A2 equals %F comma A3 equals %F end quote comma, but before the closing parentheses we have to pass in our arguments A1 comma A2 comma A3 in parentheses semicolon, and then we could print that out. I typed in S2. That's a mistake. I'll go back and fix it. System.out.println S in parentheses. And that should have been an A2. Okay. So you see what I did here. I just built a string before printing it. Whereas what I've done in the past is to just put all of this stuff right inside of printf. Same deal. I just wanted you to see string.format again. Alright, anybody need to see any of this code or have my eyeballs come look on your screen?
Can you go a little bit further down?
Tell me when.
Right